Section 4, Day 2, talks more about linear equations. Today's lesson, we're going to talk about intercepts of a graph and see how they're useful in plotting a line. So we've talked about slope-intercept form and standard form, point-slope form. So we're going to start this lesson off by finding the equation of the line, but writing it in all three forms. So before we talk about any of the forms, really, we need to find the slope of these two ordered pairs. We do so by doing y2 minus y1 over x2 minus x1. Substituting the values gives us 10 minus 4 over 6 minus 3. So that's 6 over 3, which is 2. That means the slope is 2. The easiest form to start with when you know a point and a slope is point-slope form. So I'm going to start with that one. I'm going to use the first ordered pair, x1, y1, and the slope. I get y minus, my y1 value is 4, equals, slope is 2, times the quantity, x minus 3. And that's point-slope form. It's all done. They also want slope-intercept form. Slope-intercept form is y equals mx plus b. So my goal is to take that purple point-slope form and make it slope-intercept. And in order to do so, I'm going to start by distributing. Distributing the 2 gives me y minus 4 equals 2x minus 6. And then all I need to do to get y by itself is to add 4 to both sides. I get y equals 2x minus 2. And that's slope-intercept. The last form they want is standard. There are 2 requirements for standard, which we talked about before. The first is that x must come first, followed by y equaling the constant, and you cannot have fractions or decimals. So I'm going to get that green equation to have x first, and in order to do so, I'm going to start by subtracting 2x from both sides. Gives me negative 2x plus y equals negative 2. And just double check that you do in fact have x, then y equaling the constant, and you do, so you know that you're done. I'm going to talk about intercepts for a second. An intercept is where it crosses. And so if you take a look at this graph, there are 2 intercepts here. That's the y-intercept. The ordered pair is 0, 3. Here, that's the x-intercept. Its ordered pair, 1, 2, 3, 4, is negative 5, 0. Well, you can take that line and you can move it. You can slide it down and really turn it if you want. Maybe slide it over a little bit. This is a brand new line. I moved it all over the place, but there are still 2 intercepts when I move it right here. This is the y-intercept, whose ordered pair is 0, negative 1. And right here, that's the x-intercept, whose ordered pair is negative 2, 0. So these lines, for the most part, have 2 intercepts, one at each. And take a look at the blue y-intercepts first. There's something common about them. They both start with a 0. So in the x place of a y-intercept, you have 0. And it's opposite for the x-intercepts. The green ones that we have listed there, the y value for the x-intercept is 0. So it's opposite. They're going to ask you to find the intercepts of each equation and then graph the line. So I'll show you why it works in the first one, and then I'll show you a shortcut for each of these. I'm going to find the x-intercept first. To find the x-intercept, that means that you're going to let y be 0. So if I let y be 0, think about what happens to that term in the middle. And I'm talking about this term right here. 3 times 0 is 0. It's not even really there. What you're left with is 4x equals 12. So x is 3. That means the x-intercept is 3, 0. 3, 0 is right there. And you can do the same thing for the y value. Now, in the y value, that means you're going to let x be 0. Imagine as if that x term weren't even there. So kind of if I scribbled it out, because it's 0, I'd be left with 3y equals 12. And dividing both sides by 3 gives me y equals 4. That means the ordered pair is 0, 4. X is 0, y is 4. And that occurs right there. Connect them with a line, and you're done. For letter B, if I want to find the y-intercept first, that means I let x be 0. So imagine that that term weren't there. I crossed out the 5x. That would leave me with a negative 2y equals 10. And dividing both sides by negative 2 gives me y equals negative 5. 0, negative 5. 1, 2, 3, 4, 5 puts me right there. And I'm going to repeat that process for the other term. If I let the y term be 0 and I cross that out, I'm left with 5x equals 10. And dividing both sides by 5 gives me x equals 2. As an ordered pair, it would be 2, 0. 2 zeros right there. Once you have both intercepts on there, just connect them with a line. Example 2, the cost of a taxi ride depends on the distance traveled. The cost depends on the distance traveled. Before I keep going, remember that the dependent variable is y, and so if cost is dependent, that means that I need to let cost equal y, which means the distance is x. Just keep that in the back of your mind. You paid $8.50 for a 3-mile ride. $8.50 for 3 miles. Your friend paid $18.50 for 8 miles. That's really 2 ordered pairs as a disguise. The first one would be 3, 8.5, and the second one would be 8, 18.5. X before y. So they want a graph to model this situation, so I'm going to take a second and get an xy axis on there. I can actually do a first quadrant graph because there are no negative values. You have to make sure you label your axes. The x values are distance, and this is in miles. The y-axis is cost in dollars. Now I look at the x values, the distance, and they're going basically from 3 to 8. Those are pretty small numbers. So I'm going to do every other block is worth 1 and label it. The values going up the y-axis are decimals because they're dollars. So at this point, a couple different options. Let's see. I guess I'll do every block is worth 1. So I don't have to relabel that. I'll just go by ones. They want the graph. So I'm just going to put those 2 ordered pairs on there. I'll do this one in red so you can see it. So that occurs right in there, roughly. The smartboard doesn't allow me to get a very precise location. And I'll do this one in green. Once you have both of those planes on there, connect them with a line. So we're basically, in the second part of this question, trying to find the equation of that line. And in order to do so, we're going to start with slope. Save myself some room. I'm going to do that part up here. Label your ordered pairs x1, y1, and x2, y2. And substitute. That gives me 18.5 minus 8.5 over 8 minus 3. For the top, I get 10, and the bottom, I get 5, so the slope is 2. I know that the second equation wants this in standard form, but it's actually easier to start with point slope and then just get standard from that. So I'm going to use the first ordered pair in the slope. I get y minus 8.5 equals 2 times x minus 3. And all I'm going to do is pretty this up, clean it up, so that it's in standard form. Remember, my goal is ax plus by equals c. So the first thing I'm going to do to get that is to distribute the 2. I get y minus 8.5 equals 2x minus 6. I want the constants on the right and the x's on the left, so I'm going to subtract 2x next. gives me negative 2x plus y minus 8.5 equals negative 6. Make sure that you carry that negative with the 6. I'm going to add 8.5 to both sides. I get negative 2x plus y equals 2.5. I have the right order now. I just have to get rid of that decimal. Remember, the lesson on standard form says multiply it by a form of 10. So I'm going to multiply it by 10. I only need to move one spot. I end up with negative 20x plus 10y equals 25. The third part, what can you expect to pay for a 5-mile ride? So remember that x is distance, so I'm essentially putting a 5 in for x. I'm actually just going to use the green equation that we found. So negative 20 times 5 plus 10y equals 25. Means negative 100 plus 10y equals 25. If I add 100 to both sides, I get 10y equals 125. And dividing by 10 means that I'm going to spend $12.50 for a 5-mile ride.